Riemann sums, definite integrals, beginning of integration. So all we're going to do today is look at the beginning of integration. Tomorrow we're going to hammer out all the key concepts of integration. But we've been talking and discussing and saying how integration is the area we feel the least prepared for. So going back in time, just hammering out some of the definitions. Definite integral. A definite integral expresses accumulation. And I think that that's the part we're actually struggling with. It represents accumulation and net change. So when we have those initial value problems, or we have the problems asking us for position, the integral doesn't give me the position, the integral gives me the change in position. So just understanding a little bit more of that conceptually. Okay? So we started integration with Riemann sums. And every year on the AP FRQs, there is a Riemann sum with a table. So all I would want to know or understand specifically to Riemann sum is knowing that left means you start on the left, right means you start on the right and exclude the first value. Left, you're going to exclude the last value. Midpoint, you're going to pick like averages. 90% of the FRQs are trapezoids because they add back that extra step of the 1/2 and the height and then making you do all like the extra. And then just remembering that if it is a Riemann sum, you don't have to get a number answer. You can actually just show the setup. So this would be a calculator type problem because it's a 6 sine of 0.3t. Well, 0.3 is not numerically something we know. So this would be a calculator question. It would say, how can we tell the volume of water in this tank after 6 minutes? To do this, let's think about a Riemann sum approximation of the area under the curve between t equals 0 and t equals 6. Using 6 right rectangles. So what you would do is plug that equation in to y1. And then what you would need to do is say, okay, b minus a, so it's 6 minus 0 over 6, which means that each of my rectangles, or my delta x's, are equal to 1. So I need the heights at 0, 1, 2, 3, 4, 5, 6. Okay, it's not actually asking us to do it, but this is how you would set it up. So you would need your table with 0 through 6. You would get the y values from your table, and then set up whatever Riemann sum. So this one says using 6 and right, so that means I actually don't need 0. And then you would add or sum the numbers on one side. So graphically, this is like what it would look like too. So if I looked at this and I drew in those right rectangles, I have more rectangles above the curve than below the curve. And we know that this is concave down and increasing. So concave down and increasing from the right is going to be an over. Concave down and increasing from the left would be an under. If the rate is in liters per minute and the x's are in time, then if you're thinking about this in terms of the Riemann sum, so the area is the height which is in liters per minute, times the width, which is in time, which is in minutes. The unit for area is going to be liters. So each area or each rectangle would represent volume, because liters are volume. It's like Coke is in liters, bottles are in liters. When we add up all of those values, then we get the accumulated volumes for the total water after 6 minutes. So if you were talking about this in words, if it asked you like, what does the right Riemann sum represent? The right Riemann sum represents accumulated volume after the amount of time. And then coming back, I feel like we haven't done a Riemann sum in forever. Alright. Approximate the area using a Riemann sum. So you're given a table, you're given an interval, you're told write with 3 unequal. They're unequal because the table isn't equal. It goes 0 to 3, 3 to 4, and then 4 to 8. So that means you need to have 1, 2, 3 rectangle areas. You need the base of each, which is the difference between them. And then, because we're doing a right Riemann sum, we're going to take all the base widths and pick the right heights. Okay, so the area we would say is approximately 66 units squared. Trapezoid, 4 equal divisions. So what makes equal nice is equal means you can factor out the h. So that means when you do your 1/2, all of these are the same. So you can bring out, see if I can, yeah. So like 1/2 height will be out in front. And then you just have to double all of the inside numbers and add the outside numbers. Remember doing that? Yeah. I think this was from my So this is a multiple choice style question from back in the day. And it said which of the limits is equivalent. So remember, this was like that crazy formula for you to do b minus a, so you got pi. So then you needed the answer that had pi in it, so that then it could not be letter B, because the pi told you the width, and then the starting point was what you like added or subtracted inside your parentheses. So really that doesn't help us on any of them, because inside are all not adding or subtracting anything. So you're looking for the b minus a in both the inside part and the outside part, thus making our correct answer. I was the only one that had the pi inside. Like I said, easy Unit 6 review.